Hello, everybody. So, back to start week 3 of this class. 8-week classes go quickly. We're almost halfway finished. Got a few things tonight. We were talking about before the recording started, and everybody's here, but there was one thing we kind of ran out of time for last week. It would have fit. It only took like half a page of notes, but we've been looking at stuff for like 2 hours straight that day. So I'm going to push that back till today. It can be a useful feature. Some people really like it. I almost never use it myself. But we'll see that in a second when we run out of time for it. And then we'll look at branches, which is our main way of getting alternate versions on a repository. And then cloning and pulling the repository. So working remote repositories. And for tonight, our first look at remote is going to be something like the main repositories in the downloads folder, and we're working over in the documents folder. So not very remote, but the general idea that it doesn't necessarily have to be some big fancy thing. That example I sent out is actually something I was making for class examples. A very stripped down for any data structures that we would only see in a classroom, not the way we would actually use data structures. But last time I taught the Python course on campus covering the data structure, I didn't get time like to prepare ahead of time like I expected. So I was just doing the algorithms from memory, which is a little odd when teaching a class and keeping track of everything, that do it all from memory. So I like to have examples around. Even though I know it, it's still nice to have that to look at. So I was typing up the example of that. So that repository is actually going to be on my Google Drive. It's never going to make it on GitHub. And when I'm in the class, I'll just that would have been a good example for. I could have just left it on Google Drive and sent y'all the link to it. There's something other than. But wherever we're at, working someplace different than where it actually is. So that's the main thing tonight after branches, cloning and pulling and the difference between them. A couple of the differences between them. Again, Git is absolutely massive, and in a classroom where we're covering it in 8 weeks, we wouldn't have time to practice stuff, so we're just looking for a good foundation here. So we need to look at this one thing that actually went with what we were covering last week. Those other little things that go with commits and managing the commits, and which all reverts and reverting and resetting a repository. We had to check out different branches or different commits and look what was going on, read through the logs, see all that different stuff. It's a lot of work. It'd be nice if that process was automated, right? So that's the thing that's left is bisect, which kind of automates a lot of that process. I thought that would make a nice introduction to it. That being said, I almost never used bisect because it automates the process, including like an irreversible delete without a confirmation message. I've messed things up more than I've fixed things with bisect. When I was getting these notes ready for class, so I'm going to go ahead and open the File Explorer and go over to my working directory. So we have something to work with, document/delete. When I was getting things ready for class, I did the bisect one 3 times. And at first I thought I got it right 2 of those 3 times. Didn't like go break stuff. And when I went back and or thought about it, I already deleted the print work by then. But I think I did mess it up one of those 2 times. I thought I got it right. So it automates the process, and I have definitely broken things with that automated process more than I've fixed them. But it can be useful. So we need a repository to work with here. So I'm going to my working directory and open up PowerShell like normal, or whatever terminal you like to use. Git is cross-platform. The reason that we have Git bash is because Git was created using bash scripts. So if we're on a Windows machine, we need to have those bash scripts running. If you're on a Linux or a Mac, you already have that system. so you don't have to have extra steps. But so Bash shell is kind of preferred, but PowerShell has some nice advantages. Bash uses that old syntax from like the late 70s, early 80s that seems kind of out of date compared to our other things. That's the reason I always use PowerShell. The modern syntax. For loops look almost identical to for loops in Python or Java or any of our modern languages. They don't look like the for loops from COBOL. So we need a repository here, so I'm going to make one. I'll make a new folder called buggy. This is for dealing with bugs, is what this is for. A way to track down and deal with bugs. So if I go in there and initialize that, all things we've seen a few times before, right? Initialize that, and I want to do several commits. So I'm just going to do one file each, and only 2 of the 4 commits are actually going to be relevant here. So like first commit, we just need some random text file. So Sublime, I'll call it stuff.txt. And I don't know, I'm not feeling very creative, so I'm just gonna write the word words there. Because this is just so that we have several commits. Some arbitrary words, you can just match the keyboard. But something so we have more than one commit. We'll stage that file and commit that. And I'll just go ahead and stick with this. So initial commit, create the repository, and we don't have an issue tracker, so I'm just going to skip the footer for now. Save that, and when we close it, it goes back over here. Which, if you have not noticed, this one often bothers me. The text editor still has focus. If I try to type, it's not showing up in the terminal. And it goes further. If I hit Control-Alt-Tab and like actually navigate back over to PowerShell, I just selected PowerShell from that list, and it's still, the text editor still has focus. So it's one of those things, as far as I've been able to tell, you still have to use the mouse there to click back on your terminal. I'm sure there's a workaround, but I didn't look that hard. I tried a few things and none of them seemed to work. So it's like, well, it's not that hard when you click there once, but it's thrown me off a few times. I have a tendency to start typing without looking at the screen. So start typing stuff and then realize the words aren't going anywhere. So now we need another commit. And this is for, well, you can tell from the name of the folder, this is for actually tracking down bugs. We need something with a bug. And the initial one, we need it to work. So I'm just going to make a little Python script. Tip calculator. Tips.py. I think we've already done a couple hello worlds and a payroll. So one of the easy examples. Meal price is going to be an input. How much was the meal? The standard examples, I think y'all are kind of familiar with these, right? And then hit Control and arrow to get back to the beginning and of that and turn it into a floating point number. Little keyboard shortcuts when typing are very, very useful. Does everybody know a lot of those from various programming classes? Hold shift to highlight things. Control, the arrow moves one character at a time, and if you hit Control and arrow, it moves one word at a time to quickly navigate around and home and in and all those normal things. Hit percent is input how much or what percent to tip. A couple of the standard examples. I guess that'll be a floating point number as well. Most Americans are quite familiar with tip calculators and payroll, so they make great classroom examples. The actual tip then is going to be the price times the 10%. And total is price plus tip. And then I guess print some output. That'll be, oh, those are binary numbers. Plus format the total to a decimal with 2 places, plus if you, oh, if you tip, plus format tip to 2 decimal places. Everybody's seen that before, right? Hopefully no surprises. I think everybody's seen Python. At some point tonight, I was gonna also ask what all languages everybody's seen. In the module 4 assignment, you can go in there and fix bugs. I think so far I have a Python one, C++, HTML. I put an error in the markdown README file. Oh, in a VBA macro. But I was going to ask what all languages people know, and I think I have to fix 2 of them. So I'll make sure everybody can fix at least 2 of those, or maybe add some others in if you know a particular language or something. Make sure that runs, right? The normal debugging process, Python tips.py. How much was the meal? 1, 2, 3, 4. Sounds like a good number. Oh, probably should have said this is a percent. I didn't do a percent or anything, but since I did this, I only made it 9 bases, so I can't do the 15% yet. I'll type it in as a smaller number, but the actual value, percents are just easy to say. They go in the English language better. Pretty close. There's a little space missing, but I guess I might as well go in here and fix this. So Sublime tips.py, we go back in here, and I missed the space there. And what percent to tip? Since percent is here, people are probably going to enter the whole number that said like 28%, 10% or whatever. So we need to divide that down. Well, it's in the name percent. Percent means divide, and cent means 100, like century. Did everybody see that was following along? Or at least know the correct version of that calculator? Those are my great examples, because as Americans, we see that all the time. So 1234, tip 25%, and that looks like it's all working. All right, that works. So let's commit this to the repository, stage the file, open a worker commit log, and add tip calculator. Put a program in here. Nothing too fancy. The thing we're actually going to look at is going to depend on almost the next step. I want to put now just another random text file in between them. In between this and actually going back and putting a bug in that program. So the Git will automatically find that bug for us. I'll open up the text editor with, I don't know, maybe just notes. So step 1, well, I'll make notes about what we're doing. Bisect. Step 1, find a commit where the bug did not exist. Step 2, find a commit where the bug does exist. Step 3, Git will track down the problem for us. It's not AI, it won't go do automated testing or anything. It'll just help us narrow it down, which in our case isn't gonna be much, but in a larger situation where you have lots of team members, and you got 20 team members all making commits, and it's a day or two before anybody notices the bug, there's gonna be a lot of commits and changes to dig through and things stashed in the background and all of that in order to find it. So once again, add that to the repository, just have a few things here, git commit, and add notes, make some notes about what a bisect is. Save that, close that, all stuff we've seen before. I guess now we can put in a bug. So if I open that program back up, tips.py, and I'm going to leave price as a string. Everybody's seen that before Python, right? That was probably the errors you were seeing the first week of your Python course, or your very first intro to logic course. But I'm going to close it and not run it. We know there's a bug there, and I'm just going to go ahead and commit that file. Git commit, add the bug. The bug appeared in the program. At this point, we know where it's at, but we kind of have to use our imaginations, and maybe one more random commit afterwards. So Sublime, I'll do a readme. Readme.md. I guess it's like a tip calculator. Tip calculator project. A program to calculate tips in a restaurant. Nothing too fancy. It's really just a random thing so that we can have a commit. We can have other stuff surrounding that bug we introduced. And then that process again, git add that file, git commit, include a readme. Put a readme file on the project. Most of that we've seen before. Hopefully everything looks familiar. Even y'all have probably encountered that bug before. A very common one. So now if we go looking through our repository, everything's there. It looks all fine. I guess the issue would show up. We were checking things and went to run that program now. So Python tips.py, and the meal was 1234, tip 25%, and there's a bug in our program now. So somewhere along the way, a bug showed up in all that code we wrote. You just kind of have to use your imagination a little for something a little bit more than this. So instead of digging through every single thing manually, that's a lot of work. Even a small one like this, that'd take a minute to go through all the different commits, go check out all the different commits and find where that actually showed up and dig through it. So Git can handle that for us with the bisect. So if we run git bisect, and really I should put start here, but I'm going to leave off start because if I leave off start, it will tell us we need to use start. I've seen other error messages. Sometimes it says the bisect has not been started, so we have to do that first. I guess it was still there. So git bisect, and we want to start the bisect. And now it wants to know what commits are good and what commits are bad. We know there's a bug in there somewhere. So if we say, pull up our commits, we know that it was bad by this point. That's where we actually ran that. We actually know it was bad at this point. So git bisect bad, and here's where we did the check. So we know it was bad by that last commit. Now it's waiting for a place where we know it was good. And way back here where we created it, we know it was good there. So git bisect good at this point. If you're wondering how I select, I just double click on that to select it. That should work on all the machines. Just double click on that and then copy and paste that commit name in. So 0 revisions left to test after this. 1 step. Oh, actually, it got it right. It thinks that at E6DDDBE, the bug showed up. And it guessed it right there, but notice it already deleted it. So if it guessed it wrong, it would go ahead. When you run that, it will delete the settings. It will delete it. So that already got rid of the bug for us. I think. No, actually, we went, nope, it did get rid of the wrong one. It went 1 step back. So then we could check again. Python tips.py, how much was the meal? I use the same numbers, 25% tip. Oh, the bug's still there. Our bisect is still running. We haven't ended it yet, so it's still going. So we just bisect. Well, it was still bad at this one. Copy that, paste that in. Roughly 0 step. Well, there's 0 steps. So get log 1 line. So it brought us back a step further. And we can check again. It should be good at this point, right? Tips.py. Enter the price of the meal and the tip. And we got back to where our program was working. So you want to be careful though, because I think I can end this. Is there an end command? No. I usually just stop doing anything with it, but again, I often avoid this because I have broken things more than I've fixed them with this particular command. So it automatically deletes as we walk back through there.
Is that a Mac thing? Mine did not do that.
What did yours do?
It just spit out the same, like I did get log 1 line and it just kept the bug.
Okay, I had to do it twice to get back to the previous one. The thing I was looking at is that wasn't committed, that wasn't created until way later. So I did reset. So git log 1 line, and you'll notice everything can come back. So after you're done, if you need all those, so it deleted an extra one. So this time I'm going to say git bisect start, and that should start a new one. So git bad, and it was bad here at this line where we added this. So I'll copy that. Oh, whoops. Git bisect bad there. And git bisect good at this point where we added it in. If we check the log, Notice it deleted everything back to that point. So even if starting at the very top and walking down, doesn't make any difference. It goes all the way back to where that bug was. If I list files out, our thing should be fixed, but our readme's gone. 25%, and it works again, but we had made more commits after actually doing that, so it's it did remove all the commits after the bug showed up. I guess it's an alternative way to do a reset. Is basically what it is, because they're permanently deleted unless we undo all of that. Which I guess it does it one at a time, so you just keep moving down.
So how do you get out of bisecting? Did I miss that?
You just start doing
It's still showing me as bisecting, like even though I got it down to where it came up as, and showed me where the bad file was.
I think the next get bisect next. I almost never use this one. Oh no, that just kept going. I guess next just walks through one line at a time. Bisect exit. I'm gonna put this up. I don't ever use this because I have broke things. I have broke things more often than I fixed them with it. How do you stop bisect? Probably lots of people ask the same question. Oh yeah, they said reset, and then you get back to where you were. Because we found where the bug was. It's more for finding the bug, I guess. I usually just keep working. I use it to automatically delete things. Get log one line, and now we know which one to revert. Get revert this one. And commit that rewrite. I suppose that's how it's supposed to be done. Get log one line. So dig it through, because the bug could show up over several commits, and then something that's not a trivial example put together in 10 minutes there. There's going to be a lot more things to dig through, so it can be very, very easy to get lost in it. So it can help track them down. I usually just go until I find it, and delete a branch or two back, but maybe that's why I keep breaking things with it, and just over the years I've learned to avoid that. There is an automated process there.
Just out of curiosity, it is possible to, so in this case, because you have commits after, and the stuff that's after is probably good because it has nothing to do with the file that's bugged, you could branch off the bugged one once you find it, fix it, and then merge back in, couldn't you?
Yes. Do it in a side branch, that would work. The next thing we're going to look at branches. So, yes, that would be a much better way. Just make a copy of your branch, bring it back, and that includes the deletion of the bug, and then merge those branches back together. Yeah, personally, I just avoid automated processes, and I want to make sure and show that to you. Try some things out, but obviously don't try it on a big important repository. Do something like this with a bunch of random text files and maybe one small script, so that you can practice trying to get it to work. I was just going to show that it exists, and because of those automatic deletes, I have broke a lot more things with it than I have fixed, to the point that I just avoid it. But I didn't want to leave it off the list because like if you were to see a blog or something said the things you should learn and get, it would definitely be on that list. So I wanted to make sure it was included in the class, but get some practice with it. The syntax is easy. It's basically those three things. All those different things that showed up in the instructions. Let me switch back in there. If we do git bisect and it pulls up the help menu, all of these are just different ways, right? Start, and then the terms for the enter the bad one and the good one. Or we could type it in, enter the good and the bad, enter just the good and the bad ones, enter the good or bad, skip, next, visualize. So you see they're all basically different ways to do that start, which commit is good and which commit is bad. Those are the three main things to enter. But you will definitely want to play around with that, see if you can find some good uses for it, because the larger the repository gets, right? That was a very trivial example. And even a medium-sized project in our modern world, there's going to be a lot of stuff to dig through. So automated processes can be very, very useful. Yeah, so, and then that thing, just a quick reminder of something we looked at earlier. If you want to look at an earlier branch, or not a branch, branches are where we're getting ready to look at. One line, if we want to look at an earlier commit, like we want to go back here and check out this add notes one, we use the checkout command. Check out this thing. So checkout is our command to go back, and then if we look at this point, if we just list things out, we see what it was at that stage in the commit. Switch dash, so I'm clear out of this and go back and make a new repository to do stuff with. So that'll work. We had lots of commits, lots of different versions. But really, when we keep committing things, we're doing the same version. That's really only one version. There's not many alternatives there. And in programming, we want lots of alternatives, but that's not the only place. In business and engineering situations, version control is great for slide decks. Put your presentation together, different versions of your PowerPoint, different versions of PowerPoint file to determine which one goes over better. It's great for music. If you're recording songs, you can have lots of variety in the mix of the song. After you get, you know what notes you want to play, but maybe not exactly sure how you want to come through the speaker together. Or websites, we probably have the same content, but when you go to show what a client hires you to make a website, probably have the same content, but you'll have 10 different CSS sheets to show them, 10 different style sheets. Version control is great for that. Have a different version, each one with the same content and a different style sheet. And that way, at the meeting with the client, you can just very quickly switch back and forth between them. We would mostly do that with branches, sort of like a tree. Everybody knows the basic tree structure, right? I'll draw a picture on the board. In computer stuff, we usually draw the root at the top. And then branch all. Things in the middle are branches. And when we get to the end, where there's no more branches coming off, those are leaves, some terminology. But we can keep branching off things. This could be our first commit, could be the third commit. We could go further. Git will allow us to go up and down the tree. I drew a binary tree, but it's not, we don't have binary restrictions. We can have as many branches coming off any node as we want. And we have lots of different versions, and we can jump back and forth to any particular version. I guess that's really where the version control comes in. Looking at the commits, we're looking at the same version over and over again. It's That's the source code management. So the next step is getting into our versions. So I'm going to make a new one, a new folder here. Make a directory. I'll call it Git tree. Seems like a good name. And navigate into that. And obviously initialize the repository. So there are two ways we can create a branch. Maybe I'll write those on the board. That way I can keep pointing at them. Instead of the tree structure here. Option one is we say git branch, and this is to create a branch. And then give it a name, which does follow variable conventions. It is a variable. So we will refer to the branches by the name. The commits, we will always use the number. Even though we're used to looking at the messages, that's just a tag, a string that's added on for our benefit. With branches, this is a variable. So the normal variable naming conventions, you have to start with a character or a letter. You can add numbers later, no spaces. All the normal variable conventions that you're used to from programming languages. Some special characters are allowed, but it's better just to avoid special characters and variable names. Alternatively, the one I usually use is we can say git checkout -b and then give it a name. This one just creates it. This one creates it and switches to it. I'll put some numbers here. 1, 2. If we just create it, then afterwards we still have to run git checkout whatever branch we want. So if we just use checkout with the -b parameter, it will create the branch and move us on to that branch. But sometimes we just want to create it and we'll go do stuff with it later. Keep pointing back up to those two. I think I tried to put some of both in my thing. So we need to initialize this repository. Did I do that already?
Yeah.
Okay. So it's initialized, maybe a README. Sublime README. MD or whatever text editor you use. We can add some stuff in here. Git tree, a class example covering repository branches. Save that, close it. I want to have at least 2 commits for the first example, so I'm going to go ahead and stage and add that. So I'm going to abbreviate. If we do git commit, we've been using the text file every time, but earlier and possibly before guys, we saw the .m parameter to enter a message. We also have the .am parameter, which will do add and commit in one thing. It'll shorten it to one line instead of adding the files and then putting that up. But we did see, I think we saw last week how to increase the messages we get when we stage the files. So that can be useful. But AM is add and message all in one spot. Initialize repository. Why did not add those?
So I actually didn't follow your command, and I did get add before I did the AM, so I don't know. Mine committed.
Git commit Did I remove it backwards? Initialize repository.
I've seen that AM before, I don't know.
Nope. Okay, don't know why that didn't work. I'll go back to the two-step one. Git add everything, git commit with a message for initialize. Okay, I'll double check why that was not working. But there should be, maybe it's two parameters, maybe it's -a and then -m.
Says git add -am. Is that what you did?
Oh, git add.
-am, is that what you did?
Oh, I did it on commit. That's probably why. It needs done unstable. Thank you. Git add -am. I put it on, I tried to put it on the commit instead of the add. Again, lots of ways to do it. So there's a lot of personal style. As you do it more and more, you'll get used to the ways that you like to do it. Git has been building for as long as Linux. So basically, I guess not from the beginning of Linux, from the early 2000s. So for 20 years, really good programmers have just been constantly building on here. I don't know, I need some sort of file added here. So I'll go to Sublime and make, I don't know, I'll call it greet.java. And do a hello world in Java. Public class called greet. Public static void main. Whoops. I'll try that without hitting the wrong keys. There are your strings and system.out.println hello world. Which traditional way to do it in Java. If you haven't seen that, it looks like there's a little bit more than we would do in Python. On short, Java's for big things. So if we were at one line like this, or if we were at 500 lines, it's the same setup. So obviously the setup seems like a lot more. We're just doing one line. That's actually getting shorter in August. It's been this since the beginning of Java, but once Python passed Java as the most popular programming language in the world, they were finally not locked in. Because when you're number one, you can't really change things. Everybody relies on that. And all those decades that Java was the most popular programming language in the world, they did assemble a list of things they would like to change about their language. And once Python passed them, they're able to. And August 24th, the day our fall semester starts, Java 21 comes out, which finishes the list of things they wanted to change about Java. So we can actually bypass saying it's a class as long as it matches the file name, which is a good way to do that. We can, obviously it's public and static. You can't, your initial point cannot be non-static and it has to be public because it has to be accessible. So that's trivial. And obviously it started from a terminal, so there could be some parameters coming in as strings. So all of that part's obvious, so we won't have to explicitly type it come August 24th. Or the release is August 24th. Changes coming into Java soon. I'm really excited though. I'm a little confused on what I'm going to, a little uncertain about how I'm going to treat that in the Java class in the fall, because the first day of class is the day that's being released. But that's a problem for the future. I don't think I have Java on here. I just wanted some examples. That might as well be a text file here. I'm just going to add it and not deal with compiling and testing and all that. There's a file in Java. So add that. Actually, let me try this. Git add -am in Java. I'll call it that. Nope, it doesn't know AM either. I'll have to look back up how to do that. So git add everything, git commit. I'm just going to do the commit message instead of going into the text file every time tonight. We saw that a number of times last Java version. Okay, so we got that. Got a couple files in there. Our original README, and then a Java version. And we're just starting out this project. Not really sure what's going to go on. We're still thinking, right? And before long, it's like start having doubts. Oh, maybe we should have done that in Python instead of Java. We don't necessarily need to delete this. That's where the versions come in. So let's make another version. I'll go and get branch. I'll use the first one here. So we have to, so we'll create a branch. Actually, if we just say get branch, it defaults to listing out our branches. Get branch -L would, that the -L is the parameter that's automatically applied. So that lists out our branches. Get branch, and then we give it a name. It's like, oh, maybe we should do Python instead of Java. So I'm going to create a branch called Python instead. And now if we do get branch, and I'm going to try to type -L every time for list, but it defaults to listing out the branches. So we have another version of this software that we could use. I want to switch over to that. Oh, actually, I kind of started that in the wrong place. So I'm going to switch over, and then I'm going to come back and delete it. So git checkout Python instead. So the same command we use to switch between commits is the same one we use to switch between branches. So I've listed this out. It started too late. It started after that Java file created, so that doesn't seem like much of an alternative. So instead of doing that at the beginning, at the end, I'm going to check out main, go back over here, git log one line, that stuff we've seen many times. I actually want to start off this earlier version. So I'm going to copy that and then get branch -D, and lowercase and capital D both do the same thing. Both of them are for delete, so either one will delete it. Delete that Python instead branch. And notice how this one we actually, it's a variable name, so no spaces or anything like that. Can't put it in quote marks. Follow all the variable naming conventions you're used to. Git is a linked list. And each version of the linked list is a new instance of the object, basically. So that's why that has to be a variable name. So we leave that branch, but we can create recreate it, get branch Python instead, and then paste in the start point, the point we want to start from. So start from that commit. If I list them, it's going to look just like it did earlier, but when we check it out, check out Python instead, and list out our files, you see we're back to that earlier spot. After checkout, should only see the README. I put a side note in the margins in a different bin, so I probably messed that up when I was getting these notes ready too. The whole create it and then go back and delete it wasn't in my notes. I should have read the side margins first to remember what I did. So now we can create a Python file, Sublime, greet.py, and that's a lot shorter in Python as far as what we type. There's a lot more code that runs. Anybody ever done that? Pulled up the stack, Python stack, seen how many files it actually takes to run Hello World. Shorter in the text file, but the text file is not what actually runs, right? Has everybody seen that? You can usually pull it up from idle. If you have idle Python installed on your computer. Taking telemetry is an important thing. So if we open that file that we just made, I'll just point at the button here. we're looking at the Python branch, so that's what we see in the folder. And that's where, like, if you were at a meeting for web development, showing stuff to your client, you would just change it in the terminal real quick, and then we go back to your folder. That's the version showing. So if we go to run this, but if we open the debug stack viewer, actually, I think I have to put an error. Put an error in here, save that, and then open stack view. Oh, now if I run the file, we get an error message, so our stack should pop open. Why didn't the stack open? Auto open stack viewer. Oh. Step through all the problems, we get those. Why is it not opening the stack? We get it here. Oh, there's the stack. So to run a, so we have local and global variables. Start opening this up. All of these other files have to run as well. I'm just going to open things here. Oh, I just kind of clicked on a few random ones and barely made it. All those folders filled with Python scripts that all have to run in order to print the words "Hello World" on the screen. So even though our script is shorter, there's more actually running on the computer. That's why Python never really fully took the place of Java. Or Java only moved down to the second position because Java is, we can optimize it. That extra stuff we have to type is more things we have control over. All that stuff that happens in the background in Python, we don't have any control over that. So we can't really do optimizations and stuff like that. But we're the programmers. The shorter, less than the text file is usually the option we want, right? So if we commit that, git commit, add the files, add everything, git commit. Actually, sorry, I didn't fix that error, did I? Sublime read.py. Fix the error. And in the module 4 thing where it says to fix bugs, it'll be things like that. There'll be like a letter missing from a keyword. Or something obvious, depending on the language. Obviously, C++. A letter missing in Python is like a namespace error in C++. So if you know the language, it's small, trivial things like that. Git commit -m. Added a first script, which I broke away from the naming conventions. Remember, the naming conventions is present tense. But as humans, we tend to do things in past tense because thinking about already did that. Now, if we say git branch, we still have 2 different branches. They have different things on them. This one has a Python version. And if we check out our main branch, it's got it in Java. Another branch with a random text file and commit. So what I have in my notes is to make another branch. So always check on which branch you're on. Oops. Git branch. I actually forgot that this morning, so I'll probably say it several times tonight. That one I sent out when I got to the office and downloaded it, make sure it was all there before I deleted it off my local computer. I did notice that when I sent it to you, I was on the incorrect branch. I meant to send it to you on the main branch, but I sent it to you all on a different branch. So often that's another one that goes right there with log. Check to make sure you're on the correct branch every time. So another branch. So this time I'm going to use the checkout. So instead of doing the branch, create the branch and then check out to switch to it, if we do git checkout dash B and then feed in some name. What version of the next? Oh, I'm gonna do something with HTML on the next page of the notes. Notes. Some notes. And notice this time it's switched to the new branch. Notes.txt. Trying to decide whether the project should be in Spring Boot or
And this branch came off the top of the main branch, correct?
Yes.
Because
Yes.
we didn't specify the first commit, so it started from the top of the main, which means it has your original Java.
Yes. Thank you, Nathan. I probably should have mentioned that. That was in my notes to start from the top of the main branch on this one. And you'll see why we're starting from different places in a moment. So just some notes here. Really, it's just another thing to have a commit here. So add those and commit, dash him, notes to hold thoughts. Make a pro-con list, start trying to put the project together, do one version in Spring Boot, which is the most popular framework for Java, another version in Django, the most popular framework for Python, and kind of compare them. Which in the SDEV 220 class, you would have probably seen the HTML templates. I start to bring, like, things go together. Once you get used to it, it goes together quickly. But there's a lot more stuff there too. It's automatically taking telemetry for you. If you build an API in Django, I know this doesn't get seen in the SDEV 220 class. Every time somebody registers that API, Django keeps track of that. That's what's in that SQLite database that's there. So at any point in time, you can go back to any date and see how many people were accessing your API, how many people looked at your page. That's the stuff that's already built into a framework. There's a lot there, but we barely have time to say much more than it exists in an 8-week class. So there's so much to cover. But the big powerful frameworks that have stuff to do, there's lots of different ones. And just like programming language, you just want to learn one framework really well. Because the other frameworks, if you learn Django really well, jump over to .NET with C#, Spring Boot with Java, and any of the full stack options you'd know what to do on a framework, and then it's just a syntax change. So what was it? Oh, so git merge. Okay, so now we have several branches. I was on the other branch, right? Git branch. So I'm going to switch back to the main, git checkout main. I'm going to keep those notes off to the side. So git branch. And I'm going to go ahead and merge that Python and Java. So, yeah, I'll go ahead and merge those first two, the main and the Python. That way the Java and Python, just put them on the same thing. I guess my example is kind of falling apart at this point. So when we have the different branches, this is where you would do like edits. So I was talking about two different approaches on this. Maybe I'll do the notes. So git merge main with some notes. So which one? Two of those names. We just want to merge those together into a single alternative. Although I just remembered why I was going to go with the other one. I don't think this is going to show too many. Git log one line graph, and since that came out right off there, it still kind of looks the same, but we see it there in the head. So now instead of head pointing at main, which I probably could have done a moment ago, we've seen that a few times though, right? We've seen the log a few times. Head is pointing at two different branches. So they're still held slightly differently. Now I'm going to go ahead and merge it all together. So git merge main with Python instead. And there's no, these were all additions, right? We didn't go back in and edit anything. If we just add stuff or take it away, the simple changes, it will just overwrite it. That's called a fast forward merge. Can't remember what ORC stands for. Fast forward is the quickest one. I think fast forward is where you only change one file. Like one file was changed and all you did was add 3 lines to that file. And they were written after the earlier version, so that just adds them in there. I can't remember what ORC stands for, but there's nothing that would cause problems. Next week we'll look at causing when we have problems with conflicts.
So just a quick question. This would be considered a pull request, a merge, or is it this different thing?
So a merge, yes. So this is what happens at the end of the pull request. Usually what we're talking about next week is more what we think about when we make pull requests.
Because I just wanted to make sure that I understood the language in your assignment. When you said create a pull request, you mean merging the 2 branches, right?
Yes.
Okay.
Yes.
Thank you.
A pull request is sort of asking for the branches to be merged. So we typically use pull requests because anybody can request us to combine 2 versions or switch to a different version. But not everybody has permission on the repository to do that. So the merge is like the solution to the pull request. So really the pull request would be asking for that to happen, because the person in charge of the repository can still say no. Right? The request part of that word.
Yeah, you would need an approval process and all that stuff with a pull request. Yeah. Okay. Yeah, I was just confused by the.
Yeah, we might say pull request, but normally this would be the approval of a pull request. Pull request is asking for a merge to happen. Okay, so now we've merged those. There was no conflict, so we didn't have to do anything fancy. And I'm going to pull up the thing and add in this other parameter. I put it in last time, but it didn't really do anything. Whoops. Let me clear that. Get log 1 line graph. So adding that other parameter, notice we're starting to get some lines that indicate what's happening. So from our initial things, we split off into 2 branches from that very first thing. And then on the main branch over here on the left, we added some stuff on Java, did some other stuff it was on a separate branch, but it merged back. Like we didn't make any changes that were significant enough to count as a different branch. So it kept it over there at the left. But see how we get those lines showing us the different branching and the tree structure it's taking. I want to actually now's probably a good time for a break. It's been about an hour, and the next thing is kind of showing some points that can go wrong, and then we'll come back and add more branches and look at that tree structure and stuff and how it grows. Make sure everybody's able to follow that. 10 minutes sound good to everybody? So my laptop says 7:06. Does anybody have any questions before we take a break? See how to create a merge, or create a branch and merge them back together.
So the main branch is on its own branch, and then the Python and the sum nodes are on another branch.
So they were, but then we brought them back together.
So now they're all together.
Yes.
Okay.
So now they've all been combined back into one branch. And it kind of indicates where the different branches were. And instead of putting it on the earlier log, it threw some notes in there with main that said these are combined. But now that everything's been combined, we see the different, I often use spiderweb, refer to it as a spiderweb. That's what it looks like to me, but at this point, it doesn't really look like a spider. It's gonna look a lot like a spiderweb when we add after the break. Does that make sense to you? So right now, we're back to we just have, well, we still have separate branches. We can still jump over to that branch and make changes there, which is actually the next thing to do after a break, but 10 minutes sound good? Okay, my laptop says 7:07. We'll get back to it at 7:17. I'll see y'all in just a moment.
I'll start this in Frankel.
More history.